Welcome to the Corf tutorials. Today we will learn how to use equations and size a restriction orifice. Let's start with a typical system containing a vessel, 5 pipes, a pump, and 1 restriction orifice. This arrangement is known as spilled back, and it is commonly used to guarantee a minimum flow through the pump. Assume that we have a low-pressure source vessel, F1, operating at 35 kilopascals, and need to deliver 50,000 kilograms per hour at a certain location, TK1, at a minimum pressure of 250 kilopascals. The pump manufacturer specified that the minimum continuous stable flow is 15,000 kilograms per hour, so we would like to design a restriction orifice to guarantee this flow back to the vessel at all times. Double-click on the feed F1 and change the pressure to 35 kilopascals. Change the type to vessel. There are no requirements for minimum level or nozzle elevation, so let's assume that there will be always at least 2 meters of liquid, and the discharge nozzle is at 0.8 meters above the tangent line. Click OK. Next, double-click on the product TK1 and specify a pressure of 250 kilopascals. Keep all the other values and click OK. At this point, we have specifications for the source and the main product node, so we can move to the secondary product, or the spill back line. The idea is to ensure that the final pressure of this line is slightly higher than the source vessel pressure. We could simply add a higher value like 36 kilopascals, or we can use Corf's equations and specify a delta. Let's use the second alternative. Click on the return product, TK2, and insert the letter E for the pressure. This stands for equation and means that this value would be dynamic and based on other results. There are 5 types of equations, and Corf will select the proper type depending on the type of node. For feeds and products, Corf automatically selects a type 2, and it allows to specify pressures. To see the equation parameters, go to the Notes tab. Note that clicking on the equation number field gives you information about the equation form. Alternatively, you can use the Help and Search equations in the Equipment submenu. From the dialog, we can see that the equation 2 has the form P equals C1 plus C2 times P reference, where P represents the pressure that we want to calculate. C1 and C2 are constants specified by the user, and P reference is the name of the equipment used as reference. For this case, we're going to use C1 equal 25, or 25 kilopascals above gauge, C2 equal 1, and P reference equal F1, or feed 1. Click OK to close the dialog and save the equation parameters. Then double-click on the pump and remove the pressure drop specification. Click OK. Finally, double-click on the restriction orifice and remove the pressure drop specification. Click OK. We have all pressure specifications ready, and now we can concentrate on flows. The requirements state that we should deliver 50,000 kilograms per hour to TK1 and maintain 15,000 kilograms per hour at all times through the pump. Under normal conditions, the flow to TK1 would be enough to meet the pump vendor specifications. But if the flow is interrupted, the spill back line would guarantee a correct pump operation. The drawback of this arrangement is that the return line is always open, and therefore, during normal operations, the pump will process additional flow. To calculate the orifice, double-click on the product segment, L3. Go to the Flows tab and specify a flow of 50,000 kilograms per hour. Then go to Pipe and remove the diameter. Click OK. Double-click on the return branch, L4, and specify a flow of 15,000 kilograms per hour. Then remove the diameter and change the length to 5 meters. Click OK. Finally, remove the size from all remaining pipes to allow Corf to determine the correct diameter based on the sizing criteria. Also, change the length of all 3 to 5 meters. Click OK. At this point, the specified variables should match the requirements, left bottom corner, and you can run the simulation. Click on Hydraulics, and after a few iterations, Corf will find a solution for this system. Click on Results to display pipe flows. Change to the Equipment tab and display pressure drop, control valve CV, and restriction orifice information. Click OK. Double-click on the restriction orifice and go to the Size tab. You can see that Corf determined the bore diameter, the beta ratio, and a discharge coefficient for the orifice. This information plus the pipe size, also specified by Corf, would allow to specify the correct orifice for this system. Now, let's assume that we already have an orifice, and we would like to check if once installed we can guarantee the pump's minimum continuous flow. Let's create a case so we don't lose the current information. Go to Hydraulics, Cases, and ask Corf to run Case 2. Change the case descriptions to New and Existing. Click OK to save. Double-click on the branch, L4, and add a semicolon after the current flow specification, 15,000 kilograms per hour. This would indicate that there is no flow for the second case. Click OK to save. Then double-click on the restriction orifice. Specify a beta ratio of 0.3 for the second case, or semicolon 0,3, and a coefficient equals to 0.6. Run the simulation again, and after a few iterations, Corf will find a solution for case 2. We can see that the existing orifice indeed provides an upflow for the pump. Congratulations! Now you know how to size a restriction orifice based on overall pressure drop and geometry.